Hello everyone, let's start question number 61. Consider the following statement regarding the criteria of spontaneous process in a closed system. So if a system is isolated, its entropy cannot decreases. So let's see. So for isolated systems, the delta ds is greater than equals to 0. This greater than sign for the irreversible and this equal sign for the reversible means when the system is in isolated condition, means no energy is passing through the boundary, then this entropy change is greater than equals to 0. So entropy cannot decreases. This is a correct statement. If S is a closed system of a closed system is fixed and no work is done, you cannot increases. Suppose S is constant, ds equals to 0 is equals to dq by t is equals to 0. Means what? Means dq is equals to 0. No work done, w is equals to 0. We know from the first law of thermodynamics that del u is q plus w. This is also 0. And this is a correct statement. If dA is less than 0, simple closed system, T and V constant. So constant temperature and volume from the Maxwell SPTV. We know that, this is UHGA. So A at the constant volume and temperature. This is less than 0. This is a correct answer. So correct will be D, 1, 2, 3. In the question number 62, the at 300 Kelvin, Z2 butene isomerized to the E2 butene with del G value of reaction value is minus 3.4 per kg mole inverse. A catalyst for the isomerization is added to a vessel that is kept at 300 Kelvin along with a small amount of Z butene. The mole fraction of E2 butene in the vessel when equilibrium is reached. Okay, so the given data, delta G naught R is equals to minus 3.44. This is kilojoule mole inverse. Now we know that this is equals to minus 30 ln of K. So the relation will be minus 344. If we convert to the joule, 0, joule mole inverse is equals to R is equals to 8.314. Joule Kelvin inverse mole inverse into temperature is 300 K ln of K. Kelvin joule mole inverse. So the value becomes 0 divided by multiplied this with this, it is approximately 2493. The value is equals to 1.38. Then the K value, if this ln of K, we multiply it to ln of 2, then we will get this value, because if we multiply it by 2 we get this value. Okay, so this is equals to 4, K is equals to 4. So that is equals to concentration of or activity of transbutene divided by cis butene. So we know that we have to determine the mole fraction. Basically activity directly proportional to the mole fraction. So we can say that mole fraction of Xc divided by the mole fraction of Z. We can write that mole fraction of Z is equals to mole fraction 1 minus mole fraction of E, like this. So we got 4 minus 4Xe is equals to Xc. 4 by 5, and this value 0.80, and D is the correct answer. In the question number 63, the osmotic pressure of this molar solution of was measured 300 K. The acetic acid in the benzene, acetic acid in water, NaCl in water, glucose in water. Which one of the following correct order of the increasing the osmotic pressure of the above solution? Means from lower to higher. We know that the osmotic pressure formula pi is equals to I CRT. This is called a Van Hoff factor. Okay, so the dissociation is depends upon this. Okay, when in the first case scenario, the acetic acid in the benzene, this is a polar molecule, but benzene, this is a non-polar, so dissociation is very less. So what happens in this situation, it will form the dimer, hydrogen bonding, and here OH, then hydrogen bonding, then this is CH3. So its I value approximately 0.5. It has very low value of this. For the second solution, acetic acid in water, so it will enhance the dissociation basically. So when CH3COH plus H2, its I value between 1 and 2. Okay. 3. NaCl in water. This is a weak acid, but NaCl is a strong one. So I value is 2 because it will give the 2 ions, the solution. 4 is a glucose. Glucose is a non-electrolyte. So I value is 1 basically. So highest is 3, means the NaCl in water, NaCl. After that, the 2 CH3 and COH means acetic acid in water, acetic acid in water, acetic acid in water, and acetic acid in water. Okay, and least will be 1, acetic acid in benzene basically. So option C is correct. Next question 64. Here 1 mole of benzene and its pressure in the pure state, and 2 moles of toluene pressure in the pure state mixed to form a solution. Which one of the following statement regarding the above solution not correct? Total vapor pressure of the solution is 5.2 kilopascal. Let's see. Total pressure is equals to P of benzene plus P of toluene, and P of benzene is equals to X of benzene, P naught of benzene, X of toluene, P naught of toluene. Now the value will be XB. X of benzene is 1 by 3 into 6 plus 2 by 3 into 4.8. Now 2 1.6. This is 5.2 and this is correct, not correct. So this is correct one. We have to determine the not correct option, but this is true. Down the mole fraction of the vapors of the benzene above liquid mixture is this. And generally vapor phase the mole fraction is equals to PB by P total. Pressure PB is equals to 2 and this value. And total pressure is 5.2 and its value approximately 0.38. So this is not following actually. So not correct option will be B. This is true. Next question. The correct level for the given plots of the vapor pressure against the mole fraction of the solid. This is the vapor pressure versus the mole fraction. So actually here 3 kind of option given: Raoult's law, Henry's law, and or the real solution. So we know that Henry law, this is P is equals to Xi. On the other hand, Raoult's law is equals to Pi is equals to Xi P naught I. Okay, like this. So basically Henry law follows at very dilute solution. So when Xi is equals to 0, this Henry and this is for the Raoult's, Xi is equals to 0, both P both will be 0, that pH is equals to 0 and pi is equals to 0. So if we generally draw a plot, this is pi versus xi, this is a straight line basically, or depending upon this and this, because they will give the value of slope. The slope is depends on that. So in this scenario, if we assume that kh is greater than the pi 0, means that the slope for the Henry's plot will be more steeper than the Raoult's plot. Okay, so in this scenario, the one resembles more, so that's why this is a Raoult's plot. And between second and third, we know that Raoult's law we get a in Raoult's law we get a straight line basically, and when there is any positive deviation or negative, this is a positive deviation and this is a negative deviation, so there this kind of graphs are obtained. So according to me, the second will be the positive deviation, means that real gas plot, and third one is the Raoult law plot. So the option will be follow Henry, then real, then Raoult. Option B according to me is the correct option. Now next question. A polymer X is dissolved in a suitable solvent. The osmotic pressure, the solution varies, concentration is measured at 27. The intercept of the plot against C is found to be 25. The molar X kg mole inverse. Okay, fine. Basically, here one formula is there, that is pi by C is equals to RT by M BC divided by M square. The intercept is T by M, the molecular weight is equals to 25, and this unit is joule per kg inverse. So the molar mass will be sorry 300. This is joule mole inverse divided by this is joule kg inverse 25, joule 25. Then after solving this, the value will be 99.768 kg. So option A is correct. Which one in the question number 67? Which of the following statement regarding the colligative properties of the solution containing non-volatile electrolytes are correct? The vapor pressure of the pure solvent is higher than that of the solution. That is a true statement, because in the pure state P0 is always greater than the solution pressure. That is true statement. The vapor pressure of the pure solvent is less than that of the, that is not a correct one. Only solid molecule solidify in the freezing point. Only solid molecule. This is not a right statement. So at the standard, when suppose this is a pure solvent, this is a pure solvent A. When we add B externally, this is solute. So this solute will affect the solvent freezing point. It will decrease the freezing point of the solvent. So if previously the solvent freezes suppose at 2 degrees centigrade, now after addition of the solute, now it freezes at about 1 degree centigrade. It is like that, for example. So that's why when there is solidification, the solvent molecule solidified at freezing point. That is true. So the correct answer will be 1 and 4. 1 and 4 is correct answer. Now which one among the following is not a factor affecting the boiling point of elevation constant? The elevation boiling point elevation constant formula is that Kb is equals to RTB square M1, this is for the solvent, and 1000 delta H of vaporization. So the molar mass of solute, this is true, not factor, which are the not a factor affecting. Oh, this is not a factor because this is for the solvent. Molar mass of solvent, that is true. Enthalpy boiling point, that is true. So correct answer is A. The question number 69. The Henry law constant for dissolution of the gases in the liquid as unit of, we know that the pressure is equals to kH into xi. This is a unit less quantity, so that the unit of kH is unit of pressure. So unit of pressure is Pascal. So correct answer A. Now in the question number 70, when the conductivity cell with filled with this mole per liter solution NaNO3, resistance is this, the molar conductance of the solution is given as this, cell constant of the given. So you have to determine the cell constant. The given data is 0.001 moles per liter, means this is molar solution, and resistance is 6000 ohm, and the molar conductance is given 120 Siemens semi square mole inverse. Now we have to determine the cell constant, the L by V value. So we know that lambda m is equals to kappa by C. From that we have to determine the kappa, and this is equals to C into lambda m. So concentration is given 0.001 mole liter inverse into 120 Siemens semi square mole inverse, mole cut out, and liter inverse we have to convert to the 1 liter is 1000 semi cube. Now this will be 0. So final value will be 1.2 into 10 to the power minus 4 Siemens 7 to the power minus 1. Okay, we know that G is equals to kappa A by L. So from that the L by A value will be kappa by G. Now the thing is that 1 by R is G, so this is kappa into R. So kappa value 1.2 into 10 to the power minus 4 semi to the power minus 1 into resistance 6000 ohm and Siemens is cut out, and finally we will get 0.72 semi inverse, option A. In the question number 71, the lambda molar conductance at infinite is infinite dilution value for the calcium acetate, sodium acetate, and sodium iodide solution as this respectively. The calcium iodide is, so basically lambda 0 of calcium iodide we have to determine. So the data for the calcium acetate is given. CO, this is whole 2. Basically this is given, calcium acetate, sodium acetate, OSC is also given. First of all, this is 20291 sodium iodide, this is okay. So you have to determine this. Then lambda naught of CaI2 is equals to lambda naught of Ca2 plus small lambda of CH3 CO minus, because this value is given. So this is for 2 moles, and plus is iodine, lambda naught of Na plus 2 of Na plus lambda naught 2 of I minus. So you have to eliminate this and this. Now minus 2 lambda of Na plus 2 lambda of OSC minus. So we got the value. So actually this is for the calcium acetate. Then 202 plus 2 into this sodium iodide value 127 minus 2 into sodium acetate 91. So the final value will be 274, option B. In the next question number 72, a potential difference of about 4.5 volt applied across 2 electrode placed about this. Okay, voltage is 4.5 volt and the length is 10 semi. Dilute solution of the salt X, temperature is given. How far would X minus ion expected to move? Distance we have to determine. Time is 2 hours and lambda up is given as 80 and F value is given. So the thing is that you have to determine the distance. So ionic mobility formula, ionic mobility is equals to lambda by Faraday. This is 80 by 96500 and the value will be 10 to the power minus 4 semi square volt inverse second to the power minus 1. Now the velocity is equals to mobility into the potential by distance. So this velocity is equals to distance per time is equals to u 29 into 10 to the minus 4 into second inverse 4.5 divided by this semi inverse volt this and this is semi. Now the time, now distance we have to determine. This is equals to, we have to multiply time. Time is in the second, so time is 2 into 3600 second. So finally the value will be semi. So option A is correct. In the question, the conductivity of a saturated solution of the silver chloride was found to be this conductivity. Siemens kappa value is given as 1.8 into 10 to the power minus 6 Siemens semi to the power minus 1. After correction of the conductivity of a pure water, what is the molar conductivity of chlorine ion at infinite dilution? If the molar conductivity Ag plus ion at the infinite dilution is this and the solubility product of AgCl is this. Okay, KSP is given. KSP is equals to, for AgCl, this is S square, and this value is given as 1.69 into 10 to the power minus 10. S value is 3 into 10 to the minus 5 mole liter inverse. Now kappa is given and the concentration also given. We have to determine the molar conductivity into 1000 divided by the concentration. This is 1.8 10 to the power minus 6 into 1000 divided by 1 into 10 to the power minus 5. The value is 46 Siemens semi square mole to the power minus 1. Now this is equals to the infinite dilution. So lambda molar infinite is lambda of Ag plus lambda of Cl minus. Lambda of Ag plus is given, or now lambda of Cl minus is that lambda infinite minus Ag plus, and this is equals to 6.46. So the correct answer will be A. In the question number 74, consider the following regarding two electrolyte X and Y whose molar conductivity increased by the factor these respectively. So molar conductivity versus the concentration, I would say. So we know that for this is for strong electrolyte and this is for the weak electrolyte. So it is given the X and Y whose molar conductivity increased by a factor 20 and 1.5. It's for strong electrolyte the increase is not that much, but for weak electrolyte the increase is very high actually in this point, in this region. So for X is 20, so of course weak electrolyte is X and strong electrolyte is Y. X is a strong electrolyte, no, that is not correct. For a weak electrolyte, the increase in the molar conductivity due to the increase in degree of dissociation of the electron in dilution. That is true, because when we diluted the solution for the weak electrolyte, the more the dissociation is possible. So statement 1 is false, but statement 2 is true. So correct answer is D. In the question number 75, we have to match the list 2 with the list 1. So the thing is that the ionic atmosphere, when there is formation of ionic atmosphere around a cation, the negative charge, so it will generate the asymmetric effect. Okay, A is related to 3, and B, the solvated ionic atmosphere, is its result in the electrophoretic effect. So B is 1. Option C is correct. Now in the next question, this question number 76. What is the molality of NaCl needed to so that it has the same ionic strength as this? So you have to first determine the ionic strength of calcium phosphate. So first of all, let's see the dissociation. Three minus. If the concentration of M, this is 3M and this is 2M. So the ionic strength is equals to half of MiZi square. So first of all, for first cation, concentration is 3M into charge 2 into 4 Zi square plus 2M into 9. This value will be 15M. So M is equals to 0.1. So the value will be 1.5. Okay, this is the ionic strength. The molality of NaCl is needed so that you have same ionic strength, means 1.5 is equals to half of let's suppose the concentration of NaCl, Na plus Cl minus, suppose M, this is M, so half of MiZi square, M plus M, this is equals to M. So we got the answer. This molarity is 1.5. So D is the correct answer. Match the list 1 with the list 2. Select the, okay, fine. KCl versus this is strong acid, strong base. Option C is correct. B is related to 3. A is related to 3. HCl versus NaOH, this is strong acid, weak base. So 2. B is related to 2. A3B2. Option A is correct. Okay, this is strong acid, strong base, and this is strong acid, weak base. Okay, fine. Now next question. This question number 77, 78. Okay. Here consider the following statement regarding the transport number of the cadmium 2 plus, so negative transport number, highly concentrated solution of the CdI2. That is a true statement actually. When CdI2 plus I2, this will form CdI4 like this, 2 minus. So this is resulting in a negative transport number. Okay, so this is a true statement. And in the statement 2, transport number of ions diagonally proportional to the speed, that is true, diagonally proportional to the U plus. So both statement 1 and 2 are correct. The next question, 70. Next question, during the titration of 50 ml, this is the concentration acetic acid, K is given. This mole of solution of sodium hydroxide, this is specific conductance after addition of 50 ml of sodium hydroxide. Okay, fine. Okay. So the final volume is 50 plus 50, about 100 ml, 0.1 liter. Okay, so moles of salt. So basically CH3COH plus NaOH giving the CH3CONa plus H2O. So this is a weak acid, strong base. Concentration is 0.1 molar, volume is 50 ml. Okay, so same for this also, 0.1 and 50 ml. So the final product, this concentration This is 0.1 into 50. This is 5 millimole is equals to 0.005 mole. This is the moles of salt. Now the concentration is equals to N by V, number of moles 0.005 divided by volume 0.1 liter. Okay, so the value will be 0.05 mole per liter. Okay, now the molar conductance is given. So total lambda m value is equals to 40.9 plus 50.1 to 10 to the power minus 4. So the value will be 40, 50, this is 90, 91 to 10 to the power minus 4. This is Simon meter square mole to the power minus 1. Now you have to determine the specific conductance actually. So the kappa value, we know that lambda kappa by C, kappa is lambda molar into C. So this is equals to 91 10 to the power minus 4 into concentration is 0.05 mole liter inverse into Siemens meter square mole inverse, mole cut, and we know that 1 liter is 10 to the minus 3 meter cube. So by using this, the final value will be 0.455. So option A is correct. Now the next question is that the determination of the transport number of lithium by the moving boundary method. The concentration is given 0.1 molar is taken in a cell having the uniform area cross section. Area is 1 semi square. At the end of the experiment, boundary moved by 2 semi. Length 2 semi. 0.09 gram of silver is deposited on the cathode. Silver correlates the number of conductance. Okay, the conductance of lithium plus ion, you have to determine this. Okay, fine. So the transport number according to moving boundary method, L is C F by 1000 cube. 1000 cube. Here the number of moles is equals to basically this by F. Okay, that is also called number of moles. And here for the silver, the number of moles 09 by 108, and this value about 0.000833. Now the transport number is equals to length 2 into 1 into concentration is given as 0.1 by 1000 into 0.000833. Now the final value is 0.24. Okay, A is correct option.